you can see some of the people, they get cold and they get 3 days symptom and they're out of it. Some people like myself get cold and 2 weeks down the lane we're still suffering.
Yeah.
Could you explain how human body is different in this?
Yeah, I guess we're looking at potential differences in our antigen presenting system. So I guess the easiest way to explain is you've got the two branches of your immune system. You've got the innate immune system, which are like your first responders, and then you have your adaptive immune system, which are your B cells and T cells. So your innate immune system are always what come in first and infiltrate when you have a virus or a bacteria. They come in and try and immediately remove that threat. And if they can't remove it, they send signals then to the T cells, which then help to tell the B cells to make antibodies. So your innate immune system tends to work in the first 24 hours, 36 hours, and then your adaptive immunity comes in after 48 to 72 hours. What different people will have is a genetic variant called human leukocyte antigen, DR or DQ are the codes. And that basically creates a different type of protein on the surface of the immune cells of how antigens are presented to the immune cells. So if you've got a very sensitive HLA system, it's going to cause a more rapid response or more aggressive response. And so we see when people have this HLA genetics, autoimmunity can develop because of it, because there's a crossfire of something telling the immune system that something's wrong, and then sometimes in the crossfire, the immune system makes antibodies against our own tissue. So that would be like what happens with Hashimoto's or celiac. The other side of it is when someone has prolonged illness, is it's generally a sign of either oxidative stress, so there's not enough antioxidants, or mitochondrial dysfunction.
Okay.
So the mitochondria, obviously we've got mitochondria in all of the cells of our body. The immune system is no different. The mitochondria utilize most of our antioxidants of our body, like glutathione, vitamin C, vitamin E, superoxide dismutase, catalase, all these antioxidant systems, that if we have got prolonged illness and the mitochondria aren't working properly, they're either dysfunctional in that they're not supporting the immune systems to clear out the last residual bits of virus or bacteria, or there's oxidative stress in that we don't have enough antioxidants to help the body make enough energy to support the immune system.
From the whole thing that we discussed now, I figured out our very important thing first is to respond very well is mitochondrial health and the innate immune system.
Correct.
Can I know from you how to boost mitochondria?
Yeah.
And innate system?
So mitochondria work off, I guess, two main things, and that's, we were talking about yesterday about NAD and NAD plus, and also NADP and NADPH. The NAD helps to feed into the electron transport chain. So inside our mitochondria, they create energy across this gradient of bringing electrons in and pumping out ATP, our body's energy currency. But in the process, and it's a little ironic from an evolution perspective, because as the mitochondria create energy for us, they also create a lot of oxidants like hydrogen peroxide and free radicals that our body developed, like the glutathione system, to put out the fire in the mitochondria. So if you don't have enough glutathione or enough precursors, like obviously glutathione, people probably don't realize it's a peptide. It's a tripeptide of cysteine, glycine, and glutamic acid or glutamine. If we have not enough glutamine or not enough cysteine in our diet, we won't make enough glutathione. So you've got this sort of recycling center of putting the glutathione back in. And that's where like a supplement like liposomal glutathione will help boost your body's own natural source of it. So when it comes to the mitochondria, the very most important part is protecting them against oxidative stress. So basically they're damaging themselves by making energy for us, and we come in to protect them through our antioxidant system. So it's probably the most classical example of symbiotic relationship. Like our gut,
Yeah.
the mitochondria have evolved with us to make our energy, and also, more importantly, again, when we look at the importance of the mitochondria, they make all of our hormones for us as well. So out of everything in our body, whether we always prioritize, like, what's the most important part of your body, it's either always your heart, your brain, it's actually your mitochondria. Because if you don't have enough mitochondria, or they're not working properly, you're going to start destroying parts of your body. Your cells are going to break down because of the oxidative stress.
Okay. Now, from the take I'm taking this, that if someone is using NAD plus and they don't have enough glutathione in their body,
Yeah, it's sort of, then you're adding one in but not the other.
Yes.
So you're gaining some benefits by helping with that electron transport chain, but you're not coming in then as the mitochondria making energy from the NAD plus, you're creating more fires where you don't have enough firemen to extinguish.
Yeah. So give me a protocol. Okay, let's get that. It's so important because I see in Dubai people are getting NAD plus IV drips, and then they're getting vitamin C, glutathione. IV is banned here. So let's make a protocol where this protocol is for the most healthiest mitochondria. We're taking NAD plus IV drip. We're taking a liposomal glutathione, and
you've got then peptides. So the most important peptide, in my opinion, towards a mitochondria is MOTS-C.
okay.
So MOTS-C is a peptide that encodes for mitochondrial DNA to increase the production of mitochondria. So it hasn't been approved yet in terms of like human research, but from what we've seen experimentally, it boosts mitochondria numbers quite high. And so you're creating more mitochondria, but like you said there, then part of the equation is bringing the number of mitochondria up. But if you boost the numbers and there's that dysfunction, you're just going to cause more bigger fires. So the MOTS-C, it can be complemented with another dietary supplement called PQQ.
Okay.
So pyrroloquinoquinoline, PQQ. It's what's called a pseudo-vitamin. So we think it's a vitamin that the body can't produce itself and has vitamin-like actions. But PQQ's main job is to boost the number of mitochondria that your cell produces. So you've got that side of the peptides with MOTS-C, the PQQ supplement, you've got the NAD, the liposomal glutathione, and then it's really important in that looking at even a deeper level of the micronutrients, the minerals that are very important in glutathione recycling. And so we've got molybdenum, we have got manganese, copper, magnesium, all of this playing into how our body then is recycling glutathione through our recycling system called GGT.
Yeah.
And so if we're looking at blood work to assess someone's oxidative stress, you can look at more in-depth markers of like aldehyde production or MDA, like these specific markers. But if we don't have access to those, we can simply look at GGT on someone's bloods. And if that GGT value is outside the range of 16 to 20, we know that the body isn't making enough glutathione.
Okay, that's something amazing, right? I wanna get that on the video. Okay, give me. So okay, people come to me a lot. I have a patient even yesterday. How do I measure my oxidative stress? How do I measure my mitochondria in a blood work?
Very difficult to assess the mitochondrial number. But like I said, in terms of looking at how the body is going through like oxidative phosphorylation, how we create energy outside of the mitochondria itself, we can look at a liver enzyme, or it's not really a liver enzyme, but it's always on the liver panel, called alkaline phosphatase. So ALP basically brings phosphate into your cell, and then that phosphate becomes ATP, so adenosine triphosphate, your body's energy. So you can look at ALP and see how much ALP is being made by the body, and then we can correlate that to the person's magnesium status. When we look at oxidative stress, the two biggest things inside the body that will cause oxidative stress naturally to us, aside from the mitochondria, is elevated glucose and elevated iron. They are always the two that go sort of unrecognized as being the two biggest oxidants to our body.
Okay.
So one of the processes that can actually happen with too much iron from oxidative stress is what's called ferroptosis. And it's iron-induced apoptosis. So it's actually when the iron pool of the cell goes too high, it tells the cell to basically self-destruct. So that in itself then sets off a chain reaction of oxidative stress where that cell damages the next and so forth.
Okay.
So it's really important when we're looking at, you know, bloods, looking at the serum iron level, looking at ferritin. Ferritin is one marker that often is never really paid attention to, but similarly, ferritin, the way I was explaining it and how I learned about it is it's like an empty shotgun shell in that it has iron inside it when it's stored inside the liver. But as soon as your liver releases ferritin into the bloodstream, the ferritin iron gets dumped into your tissue. So when you see high ferritin on blood work, it doesn't have iron in it. The iron has gone somewhere else. So elevated ferritin is an immediate sign of, okay, well, you've got iron overload where this iron is going anywhere and everywhere. And so that increases obviously cardiovascular disease risk.
Yeah.
It increases like neuropathy risk. So the ferritin would be another marker. Like you do have, like I said, you can check all these organic acids and aldehyde markers of oxidative stress. And MDA would be the main one that's normally checked in blood work.
MDA would be the main one to check for oxidative stress,
Oxidative stress.
along with the other.
Yeah.
Okay.
So what you're sort of then assessing there is if you don't have enough antioxidants, these markers of oxidative stress are going to be in high abundance because you're not putting out the fire, basically. And I guess one of the things when we look at oxidative stress or oxidation, we're now starting to think that a lot of disease starts from oxidative stress, where either the cell gets damaged and then the DNA gets damaged as a result, or the mitochondria get damaged and now the cell isn't capable of producing optimal energy or optimal hormones. Like cardiovascular disease, when we look at like heart disease, we have to look at cholesterol as being something important to the body for bringing fats around the body. So it's just a transportation. But when we delve into the nuance of cardiovascular disease, oxidative stress of basically not having enough antioxidants to protect your cholesterol from getting damaged.
Okay.
So once your cholesterol gets damaged, once oxidation happens, whether it's from iron, glucose, pollution, once the cholesterol gets damaged, particularly your LDL cholesterol, normally what would happen is vitamin E or another antioxidant would come along and sacrifice itself to protect that LDL. So the LDLs become damaged, vitamin E comes in and goes, I'll fix you and I'll go off and vitamin C will fix me. But if that doesn't happen, the LDL basically comes in, you've got your immune system and that basically just eats up this damaged LDL to get it out of the bloodstream to stop it damaging everything around it.
Oh.
And in doing that, it sort of triggers off these things called foam cells that are like real sticky particles. They are then pulled out of the bloodstream into the arterial wall, and that's sort of how plaque starts developing. These foam cells start sticking together.
Okay.
So from like I guess an anti-aging perspective to protect our organs, like controlling oxidative stress, your antioxidants, all of this is so important as like your anti-aging protocol.
So it is I would say one of the biohacking tricks that you just mentioned now.
Yeah.
I want to shift the conversation because it became very intense. We want to shift it to a different topic so we can keep it a bit this way. I enjoy it, it's music to my ears, but for the audience I want to keep it a bit more layman's term, I would say. Is it layman's term?
Yeah.
Okay. Stay with us. We're going to come to the next video. We're going to discuss about gut health, celiac disease, genetically high cholesterol. We're going to talk about a lot of fun stuff. All right.